Now I'm going to briefly explain what is Charle's law. Charle's law is the second law of gases that we learned in chapter 6, and it can be defined as the volume of gas is linearly proportional to the absolute temperature at constant pressure. So as long as the temperature is somewhat above the condensation point, and we are noted that the temperature is measured in Kelvin scale. And we also need to know that 0 Kelvin corresponds to negative 273.15 degrees Celsius. That is all about the definitions of Charle's law.
There are numerous good applications of Charle's law in our life. Firstly, we can see the Charle's law is applied on hot air balloon. As the air is heated by the fire under the balloon will expand. As the expansion of the gas takes place, it becomes less dense and the balloon is lifted in the air. Next, the usage of yeast in making bread is also known as the good application of Charle's law. Yeast will be releasing carbon dioxide bubbles. These carbon dioxide bubbles expand further with high temperature. The expansion of the carbon dioxide bubbles with an increase in temperature works as leavening agent and cause the bakery product to become fluffy. Lastly, Charle's law also used to explain how the turkey timer works. The thermometer or timer is placed inside the turkey. As the temperature increases and the turkey cooks, the gas inside the thermometer also expands. As soon as the timer pops, it indicates that the turkey has been cooked.
Hi, I'm Daniel. So I will talk about bad implication of Charle's law. Driving a car will heat up the tires and causing the air within them to expand continuously. If you measure the air when the tires are warm, the pressure will be higher. When the tires are cold, the pressure will be lower. So therefore, when overfilling the tires before a long trip in a hot day, the tires will have a chance to explode since the air pressure inside exceeds the limit for the optimum pressure in the tires. So this is one of the bad implications of Charle's law, which can lead to accidents and cause a very dangerous trip to everyone. So that's all.
Now we go to calculation part of Charle's law. The question for this slide is, a gas in a container has an initial volume of 4 liters and an initial temperature of 25 degrees Celsius. The final volume decreases to 0.45 liters. What is the final temperature? The formula we use to solve this question is V1 over T1 equal to V2 over T2. The initial volume is 4 liters and the final volume is 0.45 liters. The initial temperature is 25 degrees Celsius. So, we have to find the final temperature. Let's start. The first thing I'm going to do here is raise up my formula V1 over T1 equal to V2 over T2. The second thing I'm going to do before I plug in number in formula is convert 25 degrees Celsius to Kelvin. 25 degrees Celsius plus 273 equal to 298 Kelvin. Then, I'm going to substitute into the formula. 4 liters over 298 Kelvin equal to 0.45 liters over T2. So, I'm going to cross multiply. When I cross multiply, it's gonna be 298 times 0.45 equal to 4 times T2. 298 times 0.45 is 134.1 equal 4 times T2. I'm gonna divide both sides, and my final temperature in Kelvin is 33.525 Kelvin. If I had to find in degrees Celsius, I would subtract 273 from the Kelvin temperature, and my final temperature in degrees Celsius is negative 239.48 degrees Celsius.
And for the conclusion, in the experiment, we can conclude that Charles' law have many benefits in our life. This happens when the temperature of a gas is increased, its molecules gain kinetic energy and move faster. This increases the rate of collision with the walls of the container and hence increase pressure. However, since in Charles' law, pressure must be constant, the volume of the container must be increased accordingly so that the gas molecules can cover larger distance before colliding with the walls of the container. This would keep the gas pressure constant although its temperature is raised. This can be applied in many things in our life.